Okay, a couple examples finding the intervals where a graph is increasing or decreasing. All right, so as we look at this first graph, f of x equals x plus 2 squared, note that that point right there, the vertex, if you will, is at -2, 0. Right, and also realize that this graph, goes on forever. The outputs go on forever in both directions to positive infinity. Right? So if we're going to analyze this graph, I'm going to look at starting from the left to the right. Remember, x always move from left to right, and then look at the output. So if I start here, all right, I go from negative infinity all the way up to x equals -2, and it looks to me like as I move from left to right in the x direction, the outputs are going down. All right, the outputs are going down, so that's decreasing. So on that interval, so if I'm going to put that in words, I'm going to say the graph is decreasing from negative infinity. Remember, we're looking at x's as we put in here, all the way up to -2 and including -2. But once it gets to -2, something happens. All right. So now, looking at the other part of the graph, I start right at the leftmost point and move from left to right, in the x, in my inputs, right? And I notice that my outputs are increasing the whole time. So now, put that in words. The graph is increasing, and it actually gets to the point -2 all the way up to positive infinity. Okay. Next problem to look at. Right. Notice here, we can do some algebra here. But notice we got some problem in the denominator, x squared minus 1. Remember that x squared minus 1 is the same as x plus 1, x minus 1, and we're not allowed, or not in our domain, we can't divide by 0. So x plus 1 can't be 0, means x can't be -1, and x minus 1 can't be 0, which means x can't be +1. And you'll notice where that shows up on your graph is these, we'll call them asymptotes later. But we'll see that x, we can't even put that number -1 and 1 into our function. So that's what's happening here. So let's put this in words now. What's happening? So start all the way over here. And remember, we always read from left to right, just like we're reading a book. Right? So from negative infinity all the way up to almost x equals -1, we never get there. So if I want to put that in words, the graph is increasing from negative infinity all the way up to -1, but not including -1. It never gets there. So that's why we have to put the parentheses there. All right. Then we jump down. All right, get rid of that. Now we jump down to this part of the graph, still reading from left to right. And now it looks like as I read from left to right, my output values are increasing. All right, output is increasing. Shoot. Yeah, that's right. Sorry. All right, so now we're increasing. So increasing again from almost -1, right? That's my x value, almost, but not including, all the way up to 0. Now notice at 0, it actually gets there. That's an actual point on my graph, so I can do a square unit there. All right. And then if I keep analyzing, all right, you'll find that we go from 0 all the way, but not including -1. It's decreasing. My output is going down. All right. So once again, the point 0 is on my graph, but 1 is not. So that's decreasing, and then continuing on, reading from left to right. I start at almost 1, but not including, and go all the way to positive infinity. So there.